All right, so now that we know how to find increasing and increasing intervals on a function, we're going to talk about how we use that to decide whether critical points are local maxes, local mins, or none of the above. So if f prime changes from negative to positive, okay, from negative to positive, it means that the function went from decreasing to increasing, so we must have a local min. Okay, now if f prime changes from positive to negative, then then f goes from increasing to decreasing, so we must have a local max, right? Because it's even like making a little bump on my little picture here. All right, now if f prime doesn't change at c, okay, if f prime doesn't change at c, I should say doesn't change sign, then f has an inflection point. Okay, so let's see what that looks like on a picture. So relative min or local min, same thing. So we're going from decreasing, negative slope, negative derivative, to increasing after our critical point at c. That must be a local min. And in this picture, it looks like it's a global min, but we might only be seeing part of the picture. Okay, now f prime is positive. We're increasing. Here's our critical point, where our slope is 0, our derivative is 0, and now we're decreasing, so that must mean we have a relative max, right? Now what happens if I am increasing? Here's my critical point of a 0 tangent line, and then I'm increasing again. My f prime is positive, it's 0, then it's positive. We just had an inflection point. Remember, inflection points means it changes from concave down to concave up. That's not the only way to find inflection points. That only finds some inflection points, but it will find some of them. All right, now at this point right here, see, we went from decreasing a negative derivative to decreasing another negative derivative. So it must be another inflection point at that spot. So this question not only asks to find on which f is increasing and decreasing, it asks to locate all extrema. So we have to do that by finding our critical points. So remember, f prime equals 0. So f prime, I'm going to write that at the top. F prime of x in this problem is just 3x squared minus 4. So I need to know where 3x squared minus 4 equals 0. That means 3x squared equals 4. So x squared equals 4/3. So x equals plus or minus square root of 4/3, or 2 over root 3. Okay, it is okay to leave that root 3 on the bottom as far as I'm concerned. Since AP thinks it's okay, I think it's okay. All right, 2, we have to know where there are endpoints or the end behavior. Actually, to find all in extrema, you really just need to know if there are endpoints. So there are no endpoints in this, and actually we're going to figure out end behavior because of what we're doing. So we don't need to do the limits like I did on the last problem, the last example. So the third thing we need to look for are places where f prime does not exist. Now, the last time I talked about it as thinking about the graph having cusps, look at the derivative function. Is there anywhere where that doesn't have a value on the domain? Well, no. So there are no critical points on that. There's no place where you can't substitute an x in for there. So there are no endpoints. My domain is going from negative infinity to infinity. My critical points, my only critical point is negative 2 over square root of 3 and positive 2 root 3. Over root 3, excuse me, and we need to figure out the signs of f prime. We need to figure out what the slope looks like on those intervals. So I'm going to put in this middle one first because it's easy. I'm going to plug in 0 to my f prime. Well, if I plug in 0 to f prime to figure out my slope looks like, I have 3, sorry, it's doing funny things, 3 times 0 squared, wow, that doesn't look like a 0, minus 4, so that's a negative 4. So this f prime is negative. My function is decreasing. It has a negative slope. So So now let's look at one of the other intervals. All right, so if we put in something, now this, I figured out that this was 1.15 about, so I'm going to put in 2 to my derivative function to figure out whether my slope is positive or my slope is negative. So if I put in 2, I get 3 times 2 squared minus 4, so I get 12 minus 4, that's positive. So I have a positive slope, which must mean my function, my f function, my original function is increasing. So right now I'm thinking that's a local min. See, it's making a minimum, and even in my little picture here. So these arrows are telling me what f is doing. Now, over here, I'm going to plug in negative 2, substitute in negative 2. So 3 times negative 2 squared minus 4, well, that's, again, positive, because it's 12 minus 4, so it's positive. So I've got a positive slope, positive derivative, positive slope, so I must be increasing. So my critical point right here must be a max, a local max. All right, so we need to write our conclusion, and it's really important that we write each chart really carefully. So, conclusion, it asks to know on which f is increasing and decreasing and locate the extrema. So we're going to talk about f is increasing. Okay, I'm going to abbreviate increasing if that's all right with you all. F is increasing from negative infinity to negative 2 over root 3, and if you would like to write that as negative 1.15, I can live with that. And it's also increasing on 2 root 3 to positive infinity, but you have to write why. Because f prime is positive, or f prime is greater than 0. F is decreasing, okay, I'm going to abbreviate again. F is decreasing from negative, I'm sorry, I've already written that wrong. It's negative 2 over root 3 to 2 over root 3. Okay, this interval right here, it's decreasing because we knew that, because slope, f prime, was less than 0. And you could write because derivative is less than 0, or because derivative is negative, you could write that as well. It means the same thing. Now, locate all extrema, we would say that x equals negative 2 over root 3 is a relative max, because f prime changes or switches from positive to negative, okay? Or f changes from increasing to decreasing, that it would also be acceptable. So there's more than one right answer there. All right, so f prime switches from positive to negative. But like I said, you could also say because f changes from increasing to decreasing. Now, x equals 2 over root 3 has a local max, or is a local, is a local min, or a relative min, same deal, because f prime changes from negative to positive. Another way to say that would be because f changes from decreasing to increasing at that location.